All right, folks, so in this video, we're going to be starting in the guided practice on page 3, and I'm going to go ahead and hone in on number 7. Now, number 7 looks easy enough to try to factor. Folks, why are my factors not x plus 5 and x minus 1? It would be easier if I wrote it. Why doesn't that factorization work? Because that's going to give you a product of negative 5 instead of positive 5. So that pair of factors doesn't work. And in fact, no pairs of factors will work. And if we wanted to be sure about that, what we can do is type that equation into the y equals, see what the graph looks like. And on the graph, not only does this not have x-intercepts at negative 5 and 1, but what do we know about these x-intercepts? If that doesn't touch the x-axis at all, those x-intercepts are going to be imaginary, which means I'm automatically going to have to use the quadratic formula. So let's go ahead and sing the little song. Quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now from here, I've got all my values. So now we are going to plug those in to find the discriminant. So 4 squared minus 4ac. So make sure you're using the big minus sign there. And we see that we get negative 4. And folks, that is a good indicator that I've done it correctly because we said, based on the graph, this should have imaginary solutions. And how I get those imaginary solutions is by getting a negative under the square root. So from here, we simplify the square root next. So negative 4 plus or minus. Square root of negative 4 is 2i divided by 2. Now we do division distribution. And my solutions will be negative 2 plus or minus I. And we could describe those as two complex roots. Now, looking at the next one, it's in standard form. That's always our first check. We'd have to use the X method, and it's not difference of squares. I was looking at that 9 there. It doesn't look super friendly to factor. So I'm going to look at the graph first. So from the graph, this one looks like it's not exact. Ooh, but 2 looks like it could be right on the money. So I'm going to hit the trace button, type 2, and see if that really is an x-intercept. We get a y value of 0. So folks, if one of my solutions is just 2, should I have to use the quadratic formula? No, if I'm getting rational roots, I should be able to factor this. So let's go ahead and begin. I'm going to start with my factors of 9, 3x, and 3x. Factors of 8, 1 and 8. So 3x times 8, 24x. 3x times 1 is 3x. No way we're getting negative 14 from those, so those are out. Switching the order wouldn't do anything since 3 and 3 are the same. So we'll try 2 and 4. This gives me 12x. This gives me 6x. Nope, not going to be able to get it from those two numbers either. So what this means is we're going to need to try 9 and 1. So let's see, that would be 36x and 2x. Way too big. So those are out. Let's try this one, 72x and 1x. Those are way too big too. So we'll try flipping the order around. We'll try 4 and 2. 9x times 2 is 18x. There it is. 1x times 4 is 4x. So again, folks, this is why it's a good idea to check yourself on your calculator because it would be very easy to get frustrated with this and be like, I'm just going to say that it's prime. So it is factorable, but if you didn't catch the factorization, you still could solve it using the quadratic formula. Just make sure you simplify those plus minus cases. So from here, we want the 18 to be negative, which means we want the 2 to be negative, so that 9x times negative 2 is negative 18. And then we go straight across for our factors. 9x gets paired with the 4. 1x gets paired with the negative 2. Something else I wanted to bring to you guys' attention is that on the homework quiz yesterday, where it was solving, some folks got to the factoring step and they just stopped. Have we solved the equation? No, we need to find what those x values are equal to. So don't forget to do that final step of using the zero product property and setting each of those factors equal to 0. So plus 4 equals 0, 9x equals negative 4. Divide by 9, getting messy. X is negative 4 ninths. So we've got 2 roots. And folks, if you are a little nervous still about the factoring, we can hit the trace button and try negative 4 ninths. And we see that that does give me exactly the x-intercept. All right, folks, we're going to go ahead and look at our next problem. Anybody have any questions so far? All right, folks, on number 10, we're looking for a product of 6 and a sum of 4. Ooh, doesn't look like we're going to be able to do it. And if I check this on my calculator, what we find is, oh yeah, that's not going to touch the x-axis at all. So that's going to have imaginary roots, which means I'm automatically going to have to use the quadratic formula. Quadratic formula is negative b plus or minus the square root b squared minus 4 or 1/6 all over 2 times 1. And let's see. To quit out of my graph and go to the home screen, second mode to quit. So 4 squared minus 4 times 6 is negative 8. And that's good. We should be getting a negative under that radical because we said that we should be getting those imaginary roots. Negative 8 all over 2. So negative 4 plus or minus. Now that negative is going to come out as an I. Now 8 breaks down into square root of 4, square root of 2, all over 2. So then negative 4 plus or minus 2i over 2, read 2 over 2. Division distribution, we get x equals negative 2 plus or minus I read 2. 2 complex roots, there they are. Now we don't have a lot of space for number 11, but thankfully this one is factorable fairly easily. Difference of squares. Perfect square factor of x squared, or x and x. Perfect square factors of 81, 9 and 9. One gets a plus, one gets a minus. So my 2 roots would be negative 9 and positive 9. And again, folks, I could easily verify that on my calculator. Turning to the back page, we've got a few more problems on there. So on this first one, before I do anything, we need to get that equation in standard form first. Now for factoring, your a value has to be positive, and it's actually a bit easier if your a value is positive for the quadratic formula as well. So we're going to have to add 15 to keep everything positive. So 3x squared plus 14x plus 15 equals 0. Now if I go to my calculator and try typing this in, 3x squared plus 14x plus 15. Ooh, this one does not look exact, but that one is looking like it might be. So that would be 1, 2, negative 3. So if I hit trace and negative 3, we see that we get 0. So negative 3 is definitely a root. And if I'm getting rational roots, that means I should try to factor this. So let's see, 3x and 1x, only 2 possibilities for the 3, so that's nice. 15, let's go ahead and do 5 and 3. That gives me 15x. Nice. That gives me 3x. Ooh, not quite there. We'll try flipping them. This gives me 9x. This gives me 5x. Wonderful. If we make those both positive, then those will still give me the right product number of 15. So those are my factors. 3x gets paired with the 5. 1x gets paired with the 3. So then to finish the solving part of this, we've got 3x plus 5 and x plus 3. Set each of those equal to 0, and x will be equal to negative 3. And then if 3x plus 5 equals 0, move the 5 over to make it negative. Divide by 3. And x is negative 5/3. And if I wanted to verify that on my calculator, I can do trace, type negative 5 divided by 3, and boom, exactly the x-intercept. Next problem on the guided practice. It's not in standard form, and we do want to keep our a value positive just in case we can try to factor this one. So let's go ahead and add 23x over to the left side. So then we have 7x squared plus 23x plus 6 equals 0. So 7x squared plus 23x plus 6. And when we graph that, ooh, it looks like negative 3 is a root. And when I use the trace button, I see that it is. This one is in between, but if one of the roots is rational, the other one has to be rational. So let's go ahead and try to factor this. 1x and 7x. Let's do 3 and 2. 2x. 21x. Wonderful. Keep those positive. That will give me the product of positive 6 that we want. And then our factors go straight across. X plus 3. 7x plus 2. Equals 0. So then x equals negative 3. And if 7x plus 2 equals 0, 7x equals negative 2. X equals negative 2 sevenths. And if I try that on my calculator, negative 2 sevenths does give me 0. So those are my two solutions. Now on the next problem, we see that it's in standard form, and it's jumping out at me that I have a GCF. So I'm going to try to take a 2 out. So x squared is 2x plus 1. And then can I get a product of 1 and a sum of 2? Woo, we can. X plus 1, x plus 1. So we've got two factors. They are the same. So x equals negative 1 would be my only root. And if we were to graph that on our calculator, we would see that negative 1 is the vertex, and our graph bounces at that x-intercept. And that concludes the guided practice problems.